Okay, my growth mindset, math maniac Panthers. Here we go. If you can't fly, then run. If you can't run, then walk. If you can't walk, then crawl. If by all means, keep moving. Just keep swimming. Just keep swimming. Assignments due this week. 3 of them. Read it and weep. Read it and joy. Read it and just fill yourself with joy. Here's our objective today. We're just talking about using rates, more precisely, constant rates. Something that just really ratios. It's just, but ratios with time. That's really what it is. Ratios with time. That's it. We're going to have a good time, a good ratio time today. Could fill 36 juice boxes in 3 minutes. But they want to know how many bottles does it fill in 15 minutes. And I kind of backwards to color coded here. So let's just fix this really quick. I think I let, how many bottles? There we go. How many bottles? Juice bottles. Oh, I think I do got this straight here. 3 minutes, 15 minutes. See, there's our time. It's just a ratio with times. So let's see. Number of bottles filled. Oops. Blue. Right? Number of bottles filled. And then time. Right? Okay. So here it is. 63 and 3. Oh, I guess I'm doing it this way. Green, 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 green with a green in this case. And then, but this is how, we're not asking for 6 here, but how would we get to here? How would we find out how many bottles will be filled in 6 minutes? Well, if we do 63 in 3 minutes, isn't 6 minutes just twice as much time? So that's times 2. Shouldn't we be able to do twice as many bottles? Yeah, absolutely. Which is 63 times 2, 126. Again, oh, this is 3 times the time, so we should have 3 times the amount of bottles. And that's how we do it. Again, that's not what the problem's asking for. The problem's asking for this one, Mr. Hoffman. So you could just go right like this, right to the 15, right? So yeah, how do we do that? It's 3 times 5 is 15. Do the same thing up here. There it is. And well, what 63 times 5 is, dum, bum, bum. Oh, I'm so smart. Look at, I already did it already. 315. Okay, so what about 4 minutes? Ooh, that's a little bit trickier because you can't really go, well, what do you times 3 by to get 4? You could do it, but you're not going to get a nice number, nice friendly whole number here. You're not going to get that. Nope, you're not going to get an integer there. It's not going to happen. Do I mean integer? I think I do. Anyway, yeah, I think I do mean integer. Okay, so I do mean integer, right? 1, 2, 3, 4, 5, 6, 7, 8, but nothing in between. Like not 3.5, but 3 or 4 or something like that. So, I mean, because if you multiply 3 times 1, you get 3. 3 times 2, you get 6. That's too big. 1, so it doesn't. Okay, so anyway, what do we do? What are your ideas? How could we go about this? Think about it. Pause the video. I highly encourage you. Okay, here's the hint. Do you got it now? Yeah, let's find this one. How do you go from 3 to 1? Well, we're going to divide, obviously, because we're getting smaller. I mean, your choices are divide or multiply. But since the one's less than 3, we're getting smaller, we're going to divide this time. So we divide by 3 on the bottom, divide by 3 on the top. 63 divided by 3 is 21. Yeah, did you notice something though for unit rates? Really, all you have to do is take the top number and divide. I could say numerator and denominator, but I mean, they act like fractions, they behave, but they're not, so just be careful with that. Divided by the bottom number, 63 divided by 3. Yeah, here it is, 63 divided by 3 is 21. So, okay, unit rate. So now we can go from 1 to 4. 1 times 4. And just do the same thing on top, 21 times 4. And that, my friend and friends, mis amigos and amigas, we can do that with any of these. All right, so if we wanted to go 1 times 3, 1 times 4, 1 times 9, 1 times 12 to get this one up here, it would be 21 times 12. If we, yeah, see, I'll make this more clear. I'm going to take a nice blue marker here, And so we go from 1 to 12, we just times by 12. So we go 21 to whatever this thing's going to be, just times by 12. Other idea, check this out. This is one of my favorites. Mr. Boone taught me this. So you can set it up like this, like fractions, equivalent ratios. Well, going again to 4 doesn't really work, so that's not going to be helpful. So what about this way, going from 3 to 63? Can we do that? You actually can do that, because 63 is divisible by 3, which is 21. So 3 times something is 63. It's 3 times 21 is 63. So guess what we're going to do? Here's your hint. Whatever we did on this side, we're going to do over here. So we multiply this side by 21. And that'll give us 4 times 21, 84 again. Isn't it beautiful how math, it's like a game, like hopscotch, connect 4. Let's see, four square, is that called? I don't know. This is some kind of game though. Macaulay? Something like that. Okay, pause for processing. Please take a pause. Pause for the cause. Okay, word problems. Ooh, this is where we left off, I think, in our lesson. Must be a beekeeper who personally signs the jars for honey she sells. The working study rate, that means time. It's just a ratio with time. 4 jars in 30 seconds. But they want to know, if she means this rate, how many minutes? So the answer's got to be in minutes. Right away, I'm seeing something here. Will it take, you see what I see? Minutes, seconds, minutes. Uh-oh. Will it take her to sign 100 jars? So we could just go, okay, 4 jars and 30, notice what it says here, seconds. And we want to know how many minutes. So that goes with time. How many minutes? Because here's time, so this has to be time. If time is on the bottom here, time needs to be on the bottom here. But this says they want to answer in minutes, so there's something we're going to have to address. So, but the top is 100 jars, so this we can put up there. This is 100, jars. So we do have jars over here. This is 4 jars. So we do have this kind of aligned. We have jars with jars, all right? And we have, pick another color. How about orange? Time with time. But the problem is these times are in different units. They need to be the same units. So let's convert. Either we have to convert, well, they want the answer in minutes, so we have to turn this into minutes. 30 seconds is how many minutes? Well, 60 seconds, we know, is 1 minute, right? Ooh, we're running out of space. Let's put it up here. So, but we don't have 1 minute. We have, we don't have 60 seconds. We have 30 seconds. That's it, 30 seconds. So we want to know how many minutes would that be. So how do you go from 60 to 30? Divide by 2. So divide 1 by 2. Does that really help us? What's 1 divided by 2? Well, now you got to come up with a decimal. It's 1/2, right? Because if you have 1 divided evenly between 2 people, if you have 1 pizza, you get half, I get half. So the answer is half a minute. But we don't want half a minute. We want, we do want half a minute. So we could put half a minute here. But I think it's going to be, they kind of want it in decimal form. So it'd be half a minute. What's the decimal form of half? 0.5. And if you did it, like 1 divided by 2, see, 1 over here to the left, look on the left side, 1 divided by, this is divided by, a fraction is really division, 2. All right, so we're running out of space. So we're going to add a new slide really quick. Ready? Come on. I want a duplicate slide. I want a new slide. Insert. Oh, having an issue. Meltdown, meltdown. Uh-oh. Aruga. Oh, we're safe. Never mind. Just kidding. False alarm. Insert. New slide. There we go. Now let's draw, partner. 1 divided by 2 is the same thing as 1 divided by 2. How many times does 2 go into 1? You can't fit it in there. Sort of, yeah. So let's put a decimal here. Add another 0. Now, let's try this. How many times does 2 go into 10? It does go into 10. 2 times 5 is 10. It fits in there 5 times, right? And then we do 5 times 2 is 10. Subtract, and remainder 0. But you got to raise the decimal. Right there it goes. So it's 0.5. So what we're saying is 1/2 is the same thing as, we can put a 0 here just to kind of have a little placeholder, 0.5. So 1/2 a minute is the same thing as 0.5 minutes. Okay, let's get into this here. Here it is. What do you notice? What do you notice? Seconds and minutes need to be the same. So we're going to change the seconds here to minutes. I already did this. It's just kind of another way. Here it is. Here's how you do it with decimal. Oh, don't forget to raise the decimal up here. There it is. So there it is. 1 minute to 60 seconds is the same thing as 0.5 minutes to 30 seconds. Okay, so if we fill out this chart, here's our 0.5 minutes, which is the same thing as 30 seconds. Here's what we want to find. We don't really need the 8, the 10, or the 60 jars. We want to go right to the 100. So how do you go from 4 to 100? Think about it. What do you multiply that by? And whatever we do up here, we're going to do down here. And that's going to give us our answer. But I'm not doing that for you. That's your job. Let's just jump for your love. Jump in. Da-da-da-da. Da-da-da-da. Jump, da-da-da-da. Ba-bum-ba-bum. Okay, so let's go to stitches. Stitches in time. You got me in stitches. That's when you laugh. Oh, you got me in stitches. That means you're laughing so hard your belly hurts. Stitches. Okay, so sewing machine can sew 99 stitches in 3 seconds. 99 and 3. So if we complete the table, do we want to complete the whole table? Let's see. Oh, here, let's try it like this. 99 and 3. What would it be? Well, it'd probably be easy to go from 3 to 12, but it's hard to go from 3 to 4. So yeah, let's see, what do I do here? 390. So for every 99 stitches, we need 3 seconds. So every 3 seconds, we got to have 99 stitches. We could do how many stitches would it be in 1 minute, right? Okay, so here we go. Divide by 3. Divide by 3. And again, it's the same thing as the top divided by bottom. So you could really just say 99 up here divided by 3. That's how we end up with the same thing. But the concept of proportion really goes like this, kind of going this way. It's kind of like a shortcut just to go right here and divide 99 divided by 3, sort of. But you're missing the concept when you do that, I think. Okay, anyway, unit rate. All right, so now we can do this, right? You guys can do the rest. I think you get the idea here. I do not need to go any further on this one. Here's what it looks like when you're done. See? Isn't that a beautiful thing? Students, 24 cars in 4 hours. At this rate, how many cars can they wash in 13 hours? Here it is. What are your ideas? Can you just go straight from, see, 24 cars in 4 hours? How many cars? See, how many? That's why we put that question mark. How many in 13 hours? That's why the 13 is here. Can you go from 4 to 13? Not really. So what are we going to do? Maybe go here first, right? And then after we do that, then go from here to the 13, whatever that is, right? So let's do that first. Unit rate first is very helpful, especially on this one. So divide by 4 here, divide by 4 here. What's 24 divided by 4? 6. Now we can go this way. Just multiply 1 times 13 to get 13. Do 6 times 13, and that'll give you the answer here. 13. I like to put the one with more digits on top, less digits on bottom. There it is, 78. Ah, the concept of pie. Oh, I love pie. What's your favorite kind of pie? Blueberry? No. Chocolate? No. Is chocolate really a pie? I don't even know. Apple pie with if it's warmed up, freshly baked, lots of cinnamon, and some ice cream on chocolate, vanilla ice cream on top. Yeah, awesome. It's like melting. The circumference of a circle is about 3 times the diameter. What does that mean exactly? So the circumference is, so we'll just go circumference. Let's do circumference in green. See? Do all the way around, do 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 do, right there. It's about 3 times the diameter. So if we were to unroll this green line, right, it would go up and down this diameter. Should be 3 times, I think. So it'd be like this. It'd be like, let's just pick a blue. We'll go blue, diameter blue. So it'd be like 1, 2, 3. About 3 times. So it takes 3 of these to go all the way around here. If you don't believe me, get a string. I'm telling you, grab a string, find some circle, a can or whatever, take that string all the way around like this. Cut it right there. Now pick it up, pick the string up, and start laying it across here. You'll find that you go across one, and then you'll run out of room and go back again. You'll run out of room and go back again, and then you'll get to here, and you might have just a little bit left. You'll have a little bit of string left, about that much maybe. Try it, it works every time. So what's the this is the approximate ratio of circumference to a diameter is what we're talking about. That's what pi is, right? So again, imagine the string, go around the circle, cut the string out, take the string up and down the line, and about how many times will it go? 3. I highly recommend that you do this at home. You must. It's critical. Okay, so if the circumference, we have a 1 to 3 ratio. So for every circumference we have, like this, we have to have 3 of these diameters. 1, 2, 3. That's how it is. So, whoops. So how do we go from here to here? Times 2. So what's this? Take a moment, see if you can fill this chart out and come right back. Okay, how'd you do? Let's just do this quickly. 3 times 2, 1 times, no, 1 times 2 is 2. Oh, now that we have this, we can just go straight to here. We can go 6 to 12, which is 2. So multiple times 2, we can times 2 here, which is 4. But how do we go? We can't go from 4 to 5. We can't go from 2 to 5. We have to use the 1 here. So how do you go from 1 to 5? Times 5. So we have to go 3. We must times 5. So 3 times 5 is 15. Yeah, let's clean this up a little bit. Okay, so same thing here. We want to go from 1 to 7. You multiply by 7. So times 7 here. So if you're going to go from 3 to whatever this is, just do 3 times 7, which is 21. Ta-da! So we can get this animation to work. Check this out. Ready? Please play. Play. It's so cool. Please play. Play. Be right back. Okay, so here's the animation. So, see? That's 1, 2, 3 diameters and a little bit more. If you go all the way around and you lay out the string, you'll get up to 3 diameters. See right here, there's 1 diameter, 2 diameter, 3 diameters. They show a 4th one, but you don't make it to 4. You get cut off right there. So guess what this amount represents? This little bit of amount right at the after between 3 and 4. This little tiny amount right there. Guess what that is? That's the rest of pi. Let's show you here. Here we go. So it's slightly more than 3 times the diameter. Here it is. There's the 3. That 3 there represents from here all the way to here. But see this fraction here afterwards? See, 1, 4, 1, 5, 9, 2, 6, 5, 3, 5, 8, 9, 7, 9, 3, 2, 2. Some people memorize like hundreds and thousands of these numbers, these digits after the decimal. It's insane. That's what this is. Yeah, it's a rational number. That's why it goes on forever. Yep, that's it. That's pi for you. So the exact ratio is called pi. And so what about the exact here? So this wouldn't be, you would think that, oh, it's 1 times 3 with a little bit more. It's 2 times 3 with a little bit more. It's 4 times 3 with a little bit more. So this answer we would expect to be about 12 point something, something, something. This would probably be about 15 point something, 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 something. This would probably be close to, so 7 times 3 is 21 point something, something, something. Oh, here are the exact numbers. Look at that. So it is close. 3 times 2 is 6. 3 times 4 is 12. 3 times 5 is 0.15. 3 times is 21. So what's this 98 then? 98 is 7 times that long decimal. Well, at least we just did it to 1 point, just 2 of those points anyway. Do not calculator. I bet you can do this. Try it. That's it. We're done.